Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Pharmaceutical Inorganic Chemistry MCQ series, your exam power boost. Today we are going to discuss about antidotes. Prepare, practice, succeed. So under the antidote, we are going to discuss about poison and antidote, definition of this poison and antidote, classification of antidotes, and examples of the compound sodium thiosulfate, activated charcoal, sodium nitrate. So these two are used for the cyanide poison treatment, and the activated charcoal is act as a universal antidote. So antidote first, what is poison? So a poison is on any substance which when introduced into the body in relatively small amounts by any route, oral, inhalation or injections or absorption, produces harmful or toxic or fatal effects. So it is called poison. Antidote means an antidote is a substance that counteract and neutralize or prevent the toxic effect of a poison by physiologically or chemically or pharmacologically. So it is called antidote. So classification of antidotes are physical antidotes or mechanical antidotes, chemical antidotes, and physiological antidote. Physical is different, physiological is different. Chelating antidotes and universal antidotes. A poison is a poison is the best defined as a substance which, option C, produces toxic effects in small amounts when introduced by any route. Which of the following statements correctly differentiate a poison from a drug? So option C, poison produce harmful effects at a small dose. An antidote is defined as a substance that, option C, counteract toxic effects by physiological, chemical or pharmacological means. So next we will see about the classification of antidotes. First is the physical or mechanical antidotes. So its mechanism of this antidote is prevent absorption of poison by absorption or dilutions or coating the gastrointestinal tract. So example of this antidotes are activated charcoal. So activated charcoal, it is counteract the poisons of alkaloids, glycosides and many drugs, and it's act as a adsorption of poison. Adsorption, AD. It's not a absorption, it's adsorption poison. Milk is a type of antidote. It is counteracting the corrosive acids and alkalis. So it is a key functions of this is dilutions and coating. And egg albumin. Egg albumin mainly is counteracting the poisons of heavy metals, and it is action by protective coating. Demulcents like starch and gums, it says counteract poison contracted by irritant. So thereby it produces soothing effects. Next is a chemical antidotes. Chemical antidote is a react chemically with poison to form non-toxic or less toxic substance. So that means toxic substance converted into non-toxic or less toxic compounds. So example, sodium nitrate plus sodium thiosulfate. It is used for cyanide poison. Here it's mainly convert the cyanide ion into thiocyanate ion. Thereby cyanide is a more toxic effect. Thiocyanate is a non-toxic substance. Dimercaprol, it is counteracting the arsenic and mercury poison. That means removing the arsenic and mercury poison by the chelation. So chelation is nothing but, so this ion, the dimercaprol form complex with these ions. So that is called chelation. Chelation means it's forming the complex between the poison substance and the antidotes. EDTA, it is counteracting the lead poisons act as the chelation. Potassium permanganate, it's remove the alkaloids, is removing the alkaloid poisoning. It is action through the oxidation. So oxidation, potassium permanganate is oxidizing the alkaloid so that it's reducing the toxic into non-toxic substance. The activated charcoal act as an antidote mainly by option C, absorption of poison in GIT. Which physiological antidote is preferred in poisoning with corrosive acids and alkalis? So option C, milk. Egg albumin is useful in heavy metal poisoning because it, option C, form a protective coating. Demulcents such as starch and gum act as antidotes by, option D, soothing and protective action. Sodium nitrite and sodium thiosulfate are used together in the treatment of, option C, cyanide poisoning. Dimercaprol act as a chemical antidote by chelation. So, dimercaprol chemically binds arsenic or mercury through chelations and forming non-toxic complexes. So, complexes means chelation. EDTA is specifically used as an antidote in poisoning with, option C, lead. Potassium permanganate act as an antidote mainly by, option C, oxidation. So next is the physiological antidotes mechanisms produces opposite physiological effect or block receptors. So it's called physiological. Physical is different, physiological is different. Physiological means is a pharmacological antidote. It produces opposite for physiological effect or blocking the receptor functions. So examples of antidotes are atropine, naloxone, flumazenil, and vitamin K. So atropine is organophosphate poison and it's act as an anticholinergic agent. Naloxone is opioid poisoning. Removing the opioid poisoning. It's blocking the opioid receptor antagonist. And flumazenil is a benzodiazepine poison. Remove the benzodiazepine poison. It is action by GABA antagonist. And vitamin K is a warfarin and its actions restores the clotting factors. Next is a chelating agent. So chelating agents, it form stable non-toxic complexes with heavy metals and later it excreted in urine. So chelators are dimercaprol, EDTA, penicillamine and deferoxamine. That means desferoxamine it's come. Desferoxamine. DESFEROX. Desferoxamine. So dimercaprols remove arsenic, mercury. EDTA remove lead. Penicillin remove copper. So it means copper when increases it leads Wilson disease. So it's remove the copper and desferoxamine is remove the excess of iron. And universal antidotes are activated compositions, activated charcoal, magnesium oxide and tannic acid. So combination of these three are called as universal antidote. Atropine is used as an antidote in organophosphate poisoning because it is, so option B, an anticholinergic drug. Naloxone is the drug of choice for poisoning with, option C, opioids. Flumazenil act as an antidote in benzodiazepine overdoses by, so option C, GABA receptor antagonism. Vitamin K is used as an antidote in warfarin toxicity because it is, option C, restores clotting factor synthesis. Dimercaprol is primarily used in poisoning with Option C, arsenic and mercury. Penicillamine is the chelating agent of choice in option C, copper accumulation. So when copper accumulation increases, it's called Wilson disease. Desferoxamine is used as a chelating agent in poisoning with option D, iron. Chelating agents acts by option D, forming stable and non-toxic complexes. So next about universal antidote, activated charcoal. We'll see. So activated charcoal is prepared by carbonization followed by activation to greatly increases its surface area and absorbing power. Next, carbonization steps. First, we'll take raw material like wood or coconut shell, peat, bone or vegetable matters is the raw material. From this only we are going to prepare the activated charcoal. So next, this raw material heated in absence of air at 400 to 600 degrees Celsius removes all volatile matter. While heating, it removes all volatile matters and produces charcoal with low absorption capacity. So next, this low absorption capacity of charcoal is heated at 800 to 900 degrees Celsius in the presence of activating agent which create micropores. And this activation is done in the two methods, physical activations or thermal activation. Charcoal is heated with steam or carbon dioxide. At high temperature, burns off impurities and open pores. Then most common method for medicinal charcoal. So this by preparing the charcoal from this method, it's mostly used for medicinal purpose. And it is called physical activation. Next is a chemical activation. So in chemical activation, raw material is treated with zinc chloride or phosphoric acid, then heated and washed to remove chemicals, produces very high surface area of charcoal. And result of this activation, the formation of numerous microspores and surface area increases to 3,000 to 3,000 meters square per gram, and it has high absorption capacity. Which of the following is a component of a historical universal antidote? So option B, activated charcoal. The universal antidote consists of activated charcoal, magnesium oxide and so option C, tannic acid. So is the universal antidotes are, it is combination of three, activated charcoal, magnesium oxide and tannic acid. The activated charcoal is prepared initially by carbonization of raw materials at option B, 400 to 600 degrees Celsius in absence of air. The main purpose of activation step in the preparation of activated charcoal is to option C, increase the surface area by creating micropores. Which of the following is the most commonly used method for activation of medicinal charcoal? So option C, physiological activation using steam or carbon dioxide. Chemical activation of charcoal involves treatment of raw material with option C, zinc chloride, phosphoric acids followed by heating. After activation, the surface area of activated charcoal is approximately option D, 1000 to 3000 meters square by per gram. So next is the antidote key factors. Antidote that adsorb poisons, AD, adsorb poisons. So it is activated charcoal. So adsorption means it's activated charcoal. Antidote for cyanide poisons act as it is used for the sodium nitrate and sodium disulfate. Antidote for organophosphate poisoning, atropine. Antidote for opioid overdose, naloxone. Chelator for iron poisoning, desferoxamine. And adsorption, dilutions and coating, it is called physiological antidote. So physiological antidote means it's act through the adsorption or dilutions or coating. And chemical antidotes working through the chemical reactions. And physiological antidotes work based on the receptor antagonism. And chelating agents work mainly binding with the ions unformed complexes. Activated charcoal is classified as which type of antidote? So option D, physiological or mechanical antidote. Sodium nitrate followed by sodium thiosulfate used in cyanide poisoning belongs to which class of antidote? So option B, chemical antidote. So because sodium thiosulfate first chemically these antidote chemically react with the cyanide ion. So first sodium nitrate forms methemoglobin. Then the sodium thiosulfate convert this cyanide ion into thiocyanate ion. Cyanide is a more toxic, thiocyanate is a non-toxic. So that means less toxic. Later it is excreted through urine. Which of the following antidotes is classified as a physiological antidote? So option C, atropine. Dimercaprol is the best classified under which category of antidotes? Option C, chelating agent. Milk and egg albumin is used in poisoning cases are classified as option B, physiological antidote. Sorry, physiological milk act by diluting or coating while egg albumin form protective coating and preventing the absorption of poisons in GIT. So it is not physiological, it is a physical antidote. This answer is wrong. So option D is the correct answer. Next is the antidote, sodium sulfate, and these are all the three compounds. They are given in the syllabus. Activated charcoal, sodium nitrate. So activated charcoal acts as a universal and physiological antidote, and the sodium thiosulfate and sodium nitrate is used for the cyanide poisoning. It is both. It's used for the cyanide poisoning. The first step is sodium nitrate is given, and second step of the treatment, sodium thiosulfate is given for the treatment of cyanide poisoning. So for this compound, synonym of these compounds and mechanism of action of this compound, sodium thiosulfate is act as a sulfur donor. It converts toxic cyanide into non-toxic thiocyanate in the presence of rhodonase enzymes. And physiological means it has the large absorption surface, large absorption of portions on the large surface area and prevent GI absorption. GI absorption it prevents. Sodium nitrate is act as oxidize the hemoglobin to methemoglobin, which binds cyanide ions, and cyanomethemoglobin free cytochrome oxidase. These are all the tests for purity for the each compounds and assay of these compounds. The molecular formula of sodium thiosulfate pentahydrate is option C. Which of the following substances does not have a fixed molecular formula? So option C, activated charcoal. Remaining three there have fixed molecular formula. The official IP assay of sodium thiosulfate is carried out by So option C, iodometric titration. Activated charcoal is assayed by determining its option C, iodine adsorption value. Sodium nitrate is assayed by option C, redox titration using potassium permanganate. Sodium thiosulfate acts as an antidote in cyanide poisoning by option C, converting cyanide to thiocyanate. The antidote action of sodium nitrate is in cyanide poisoning is due to option B, formation of methemoglobin. Activated charcoal prevents toxicity mainly by option C, physiological adsorption in GIT. Apart from its role in cyanide poisoning, sodium thiosulfate is also used as option B, antichlor. So sodium thiosulfate neutralizes chlorine. It's used as an antichlor agent. Which of the following is known as universal physical antidote? So answer in the comment box. So join in our WhatsApp community. You will get hands-on material. Thank you. Like, subscribe and share.